Hi guys, so now we're going to move on to question 6, right? And question 6 is all focused on finance. So obviously the most important thing with finance is always about time and it's always about interest, right? The longer a certain amount of money is invested, the more interest it accrues, the longer money has to be paid off over, the more interest you have to pay, okay? So interest is the big thing here. Another thing that's important is whether it is simple or compound interest. Simple interest, you don't earn interest on interest. You only earn interest on the capital amount, right? Compound interest, you earn interest on interest. Okay, so we'll look at this in a bit more detail, these concepts in a bit more detail, but let's just jump into question 6 and see what they're asking us to do. So they're saying two friends, Kuda and Tabo, each want to invest 5,000 for 4 years. Kuda invests his money in an account that pays simple interest, simple interest at 8.3% per annum. At the end of 4 years, he will receive a bonus of 4% of the accumulated amount. That's important, right? Because they're basically saying he earns a certain amount of interest and then he gets almost like a bonus, okay? Tabo invests his money in an account that pays interest at 8.1% per annum, right? PA means per annum, per year. Compounded monthly. That's important because how frequently interest is compounded determines how much interest we get. Okay. Whose investment will yield a better return at the end of 4 years? Justify your answer with appropriate calculations. Okay. So let's start with Kuda. Okay. Remember to always start your questions on new pages. But let us start with Kuda. So I'm just going to write down some information that we know, right? So the initial amount, I'm going to call it the initial, so this is for Kuda. Okay, the initial amount is that 5,000 Rand. Okay, interest is 8.1% per annum, and we need to put, it's very important that we know that it's simple. Okay, then let's see, and then there's a 4% bonus at time 4. Okay, now it's important when you say that bonus is, right? Because it's saying, how long are they doing it? For 4 years. Okay, so let's quickly use a little formula, right? So we know that there's these formulas that we're given, right, at the back, generally on the information sheet. And let us look for what we are looking for. Okay, so they've given us over here, there's simple interest, right? That's simple interest. This is simple depreciation. Compound interest, compound depreciation and compound interest. Okay, so let us now, we're going to be using this one here, right? So it says A equals P 1 plus I times N. Okay, so we know that P is 5,000. We know that I is 8.1%, right? And N is 4. Okay, so that's pretty simple, right? We can just... Wait, did I write that incorrectly? Yes, I did. Look here. I put the wrong interest rate. It's 8.3. 8.3 for Kuda. You see, it's important here because if you don't do that, you're going to get the incorrect answer. Okay, so make sure that you read your questions correctly. Okay, so let's just put that in. 1 plus 8.3 times 4. Okay, so at time 4, that is how much Kuda will have. Okay, but they also said this 4% bonus. So let's work out the bonus for Kuda. Right, so the bonus is 4% times this accumulated amount. Okay, that's what it said over here. It said at the end of 4 years, he will receive a bonus of exactly 4% of the accumulated amount. So we need to also include that because it's not just this, it has to be this plus the bonus. Okay, so let's times that by 4%. Okay, and this is the bonus. Okay, not a problem. We're doing well. Okay, so let's now add those two together. So the total amount for Kuda is the 6660 plus 266.4. Okay, put that in our calculator. Make sure you type correctly. I'm sometimes a bit of a nana and I put things in incorrectly, but that is your final answer for Kuda. Okay, so let us now move on to who's the other guy? Tabo. Perfect. Okay, so now we're with Tabo. Okay, Tabo also invests 5,000 Rand. That's also his initial amount. Okay, that's his initial amount. His interest is 8.1%, right? They told us, yeah? 8.1%, right? Per annum compounded monthly. Okay, importance, compounded monthly. Okay, he's also over 4 years, right? That's what our n value is going to equal. And let's now go to the correct formula. So it's compounded. So we're going to use this guy here. Okay, do you see here? N is within the bracket. Here, n, which is the time, is in the exponent, right? Which accounts for the interest on interest. That is the characteristic of compound interest. So let's now go and complete this. Okay, so let's write in this other formula, 1 plus I to the power of n. Okay, dokes. So we're doing pretty well. Okay, so compound monthly, that's important because now everything is in terms of months. So these 4 years must be converted to months. Okay, so that's important to remember. So let's just quickly put in what we know. So here we're going to say 8.1% over 12 because it's compounded monthly. Okay, then here we're going to say 4 times 12 because it is monthly. Okay, you have to be consistent. It's similar to when we do, like, let's say volume, right? When you're doing volume, you have to put everything in the same measurement, right? Here's exactly the same. Otherwise, you're going to get some funky dunky answer. Okay. Biggest thing is make sure that you type this in correctly. Okay, so you can put it as 8.1% or you can put it as 0.081, whatever. I'm just putting it in like this, and 4 times 12 is 48, and let's see how much. Okay, so Thabo makes 6905.71. Remember, we're talking about a currency. You only ever have 2 decimal places. There's no such thing as 3rd and 4th decimal places when it comes to currency. Okay, so what we need to do is we haven't actually fully finished the question. The question says, whose investment will yield a better return at the end of 4 years? Okay, so who is more, right? Kuda or Thabo? It is Kuda, right? Kuda has more at end of 4 years. But the only reason he actually got more is because of this 4% bonus. You see that? Because the actual difference between this amount here, which was the simple interest, and compound interest, we see that Thabo actually got more. But this bonus, right, that Kuda got, made for a larger final amount. Okay, and that's why they put it in, because they were testing you, right? Because simple and compound, often you'll see that compound, even if it's a lower interest rate, will give you a larger amount because you are getting interest on interest, whereas here you're just getting interest on the capital amount. Okay, it's a very good question, this. Okay, let's now move on to 6.2. Okie dokes. Let's see what this is all about. Okay, so now we're talking about someone else. It says, 9 years ago, a bank granted Mandy a home loan of just over $500,000. Okay, this loan was to be repaid after over 20 years at an interest rate of 10% compounded monthly. Again, how often it is compounded is very, very important. Mandy's monthly repayments commenced exactly 1 month after the loan was granted. Important, it's telling us that she pays in arrears and not in advance. Okay, and you might be like, what does that mean? Arrears means she pays at the end of a period. Advance means paying at the beginning of a period. It is important because remember, when we're talking about the time value of money, any portion of time, right, you either accumulate interest or you pay interest, depending on what side of the coin you're at, right? Right? So it's very important to know when someone is paying something. If she's paying it in advance, right, she would pay less interest. Whereas if she's paying it in arrears, she has to pay for interest over that month. Okay, so it's important to think about things like this because interest is a very powerful force, okay, especially when you're the one who's actually paying it. Okay, so let's jump into the question. It says Mandy decided to make monthly repayments of 6,000 Rand instead of the required 5,000 Rand and 5,066 Rand and 36 cents. I struggle so much to say these numbers, goodness. How many payments will she make to settle the loan? Okay, so we basically are looking for N. Okay, but we also know that she is paying an annuity. Okay, now you could be saying, Margs, what on earth is an annuity? An annuity is a regular payment. Okay, so over here, what we were talking about is we're talking about just a lump sum that was paid in, accumulated interest, easy peasy. Here, we're talking about she's paying off every month, and that's what we do when we pay off a mortgage, right, or any form of loan, generally speaking. Okay, so we know that. Right, I think we're going to use this one here. So these are the two different formulas that we use, right? So this is for present value. This is when we say this is how much she loaned and this is how much she's going to pay back. Future value is saying this is how much she's going to pay off at the end of a period, or this is how much she's going to get at the end of the period. How much does she have to contribute? So we're going to do the present value because we know what the present value of the loan is. Okay, so let's just jump into that and figure that out. So what we're going to have to do is we solve for this n over here. So let's write down all the things we know, and then we can solve this. Okay, so firstly, make sure you reference your numbers correctly. I'm just going to write down. Oh, goodness, I wrote this quite ugly. I'm going to try again. Okay, I'm going to write this down, the formula that we're going to use. Okay, just so that we know what we need, right? So let's say, okay, X we know, right? X is going to be that 6,000 Rand. Okay, so that is the amount that she's actually paying as opposed to the amount that she was required to pay. Okay, because we know if she paid this amount every month, she would pay for 20 years. And all you would then say is 20 times 12, and that would be 240 loan installments. Okay, but now she's paying more. So you would expect her to have to pay a fewer number of annuity installments, right? Because she's paying more, so she gets to pay it off quicker. So we have to solve for what this new n would be, okay? And as a check at the end, that n should be less than 12 times 20, which is 240. So we know that it needs to be strictly less than 240, okay? That's going to be a check for us, okay? So let's plug in all the things we know. So we know x equals that. I equals, so 10%, but it's compounded monthly. Important. Remember I said that this is like our measurement, okay? So we have that, we have I, we have X, and we know that P, right, that's the initial amount that she took out, is this 525,000 Rand. So now we're going to plug it all in, and then we just do some little algebra, and then we will smash out what our N has to be, okay? So let us put all of this in. Let me make sure that I'm not subbing in weird stuff. Okay, so here we're going to say 0.1, or you can say 10% if you want, over 12. Okay, because we know that it has to be in months because it's compounded monthly. Also, she is paying monthly. Makes sense. They made it nice and easy for us. So then we say minus n, because we don't know what that is, right? That's the thing we have to solve for. Over the interest rate, which is 0.1 over 12. Okay, now we're just going to take our calculator, right? And we're just going to hoy all this stuff in, and basically we're going to solve for it. Okay, so we're going to say, yeah, there's 525. So I'm going to write out all the steps, right? So if we basically are wanting to get rid of everything in order to get n by itself. Okay, so I'm going to do a bunch of steps so that you can follow me. Okay, so what I'm going to do is I'm going to times by this, because basically I want to get rid of the denominator. Then I'm going to divide by this. Okay, so follow me on my calculator as I do this. Okay, so I'm going to times it by 0.1 over 12. Then I'm going to divide it by 6,000, sorry. I'm just like lying up in here. Okay, then we do that. And then basically we're left with this. Okay, and we have, what is this, 35 over 48. Okay, then we're going to basically take that side. So we're going to minus 1. We're going to minus 1, and then we left this negative in front of here, right? So then we're going to times by negative 1. Okay, so then we get this. Okay, we're making some nice progress here. Also, it'd be nice marks if you made sure everyone can see what you're writing. Okay, cool. Okay, cool. So now we have this exponent. Now you could be thinking, oh, good grief, how do we get that exponent out? Okay, now we go back to our good old friend log. Okay, so what we can do is we're going to log both sides. So we log 13 over 45. And if you know your log rules, you know that an exponent, once we log the base, comes forward. Okay, So now it's even simpler to solve. Okay, so now we know that negative n is just going to equal log 13 over 45 over log 1 plus 0.1 over 12. Okay, and that should solve really nicely. So let's put that into our calculator. The biggest thing with these questions, guys, is just not to make mistakes. Oh, goodness gracious me. Not make mistakes when you are plugging this into your calculator. It's very easy. I mean, you've probably seen I've made numerous mistakes. But you don't want to lose marks for that. Okay, so let me just see if I've done this correctly. 13 over 40, is it 48 or 40? Did I type this in wrong? No, let me quickly just check. Yeah, you see here, guys, that should have been 48. I knew something was weird. Okay, you see, look there. You see, I didn't write it correctly, right? Because I said minus 1, so it makes sense that we are on 48. You see, I'm making lots of mistakes here, but it's good for you to see people making mistakes so that you don't make them yourselves. Okay, very important. Okay, make sure that you do that correctly and you're not like your girl Margie who's just making mistakes all the time. Okay, so cool. And then you hoy that in. Cool. So then negative n equals negative 157.40. Cancel those two negatives. So you know that n, right, the number of months that she will pay off over when paying 6,000 Rand per month will be 157.4. But you can't pay for fractional months. So n has to equal 158 payments. So when it comes to this, you always round up. Because if she only made 157, she would still be owing money, right? So at 158, the last payment, the 158th payment, it would be smaller than 6,000 that she would pay, but she's still going to make 158 payments. Okay, that's very important. Okie dokie. So that is that question. If I lost you at any stage, just go back and go over things. The most important thing you need to know is that you need to log, okay? In order to get an exponent, right, down as next to the base, you have to use log, right? And then a big learning here is don't make stupid mistakes like me. Make sure that you write what is in your calculator properly down on your page. Okie dokes. Okay, now we are moving on to our last question. This is fabulous. Okay. So, cool. Let me just check whether you can see. Okay, it says, after making monthly repayments of 6,000 for 9 years. So, for 9 years, it would be 9 times 12. Remember, because we're always looking monthly. Mandy required money to fund her daughter's university fees. She approached the bank for another loan. Okay. Instead, the bank advised Mandy that the extra amount repaid every month could be regarded as an investment and that she could withdraw the full amount to fund her daughter's studies. Right, so basically they're saying the difference between the amount she paid per month compared to the amount that she actually was required to pay per month, right, the difference there, that could have all been invested and she can now withdraw that for her daughter's education. Okay. So it says calculate the maximum amount that Mandy may withdraw from the loan. So we assume here that the interest stays the same. Nothing has changed except now we are just working out what she can take out from the loan. Basically, the additional money she has contributed towards her mortgage, which she is taking out for her daughter's education. Okay, so let's just jump into this. I just want to check I have some extra exam pad on hand because I think we're going to run off the page, but that's not a problem. 6.2.2. Okay, so firstly, let's see how much she contributed in excess of what she had to. So we know she contributed 6,000 per month, and she only had to contribute this much per month. Okay, we know that from there. So how much did she contribute in excess of what was necessary? Okay, so we say 6,000 minus 5066.36. Excellent. So she contributed 933 Rand and 64 cents more than she needed to every month. Okay. Cool. So now what we're going to do is we're going to use a different formula because, right, what we're saying is she contributed this every month, right, for 9 years. But then at the end of the 9 years, she is going to take out the investment of that, okay, over those 9 years. So we're talking about the future value, right? We want to know at the end of 9 years, how much can she take out? It's the future, right? It's not the present, it's the future. Okay, so we know we're going to use this formula. Okay, 1 plus I to the power of n minus 1. Make sure I write it correctly because that's lovely. Okay, so let's figure out what all these things are. So x, we've just worked out, is 933.64. I is still my 10% compounded. Okay, compounded, can you see? Cool, monthly. Okay, and n is going to be 9 times 12. Okay, so what we are working out is f, which is the future value. So it's quite nice because we don't have to use any logs or any funky donkeys like that. We can just hoy it into our formula and quickly solve it. Okay, let me just make sure you can see what I'm seeing. Cool. Okay, so we know that f is going to equal 933.64. I'm going to say 1 plus 0.1 over 12. 9 times 12 minus 1. Make sure you do all these things correctly. I mean, by that, I mean plugging them in correctly, because you can see I'm sometimes make mistakes. Okay, now all you have to do here is make sure that you type everything correctly, and then you will get your answer. Okay. It's actually sometimes easier said than done, though, because it's very easy to get some of these brackets wrong. Okay, to the power of 9 times 12 minus 1. Excellent. Over 0.1 over 12. Okay, so the amount that she can withdraw at the end of the 9 years for her daughter's university education is this much. Okay, remember, round off to 2 decimal places. We're talking about a currency, and that is our final answer. Okay, so the most important thing here is to use the right formula and to make sure that all of your inputs are correct. Okay, I hope you found that helpful. Let's now do question 7.